Welcome back to Singh Classes. Today we are breaking down one of the most fundamental chapters in chemistry, chemical reactions and equations. Whether you are a student or preparing for your board exams, let's dive straight into the notes. A chemical reaction is a process in which one or more substances, reactants, undergo a chemical change to form new substances, products with different properties. Example, magnesium plus oxygen yields magnesium oxide. 2. Chemical equation. A chemical equation is the symbolic representation of a chemical reaction using chemical formulas. Parts of a chemical equation: reactants, substances that react on the left side; products, substances formed on the right side. Arrow means yields or forms, and the plus sign means reacts with. Writing a chemical equation. Step 1. Write the word equation. Step 2. Write the skeletal equation. Step 3. Balance the equation. 4. Balanced chemical equation. A chemical equation is balanced when the number of atoms of each element is equal on both sides, following the law of conservation of mass. Law of conservation of mass. Mass can neither be created nor destroyed in a chemical reaction. Proposed by Antoine Lavoisier. 5. Types of chemical reactions. 1. Combination reaction. 2 or more substances combine to form a single product. Reaction. A single compound breaks down into simpler substances. Types of decomposition. Thermal by heat, electrolytic by electricity, and photolytic by light. 3. Displacement reaction. A more reactive element displaces a less reactive element. 4. Double displacement reaction. Exchange of ions between two compounds. Example, sodium sulfate plus barium chloride forms barium sulfate and sodium chloride, where a white precipitate of sulfate is formed. Redox reaction. A reaction involving oxidation and reduction. Oxidation involves the addition of oxygen, removal of hydrogen, or loss of electrons. Reduction involves the removal of oxygen, addition of hydrogen, or gain of electrons. 6. Effects and observations of a chemical reaction. Signs that a reaction has occurred include change in color, change in temperature, formation of gas, formation of precipitate, or change in state. Example, iron and copper sulfate results in the blue solution turning green. Corrosion, slow destruction of metals by reaction with air and moisture. Example, rusting of iron, where rust is hydrated iron. Types of corrosion. 1. Rusting. A specific type of corrosion that happens only with iron and requires air and moisture. 2. Tarnishing. Formation of a thin layer on a metal surface, such as silver becoming black or copper, developing a green coating. Rancidity. Oxidation of fats and oils in food, causing bad smell and taste. This is an oxidation reaction, not metal corrosion. Prevention of corrosion. 1. Painting. Prevents contact with air and moisture. 2. Oiling and greasing. Used for machine parts to form a protective layer. 3. Galvanization. Coating iron with zinc to prevent rusting. 4. Electroplating. Coating one metal over another using electricity like chromium plating on taps. 5. Alloying. Mixing metal with other elements to make it corrosion resistant, like stainless steel made of iron, chromium, and nickel. Rancidity. Oxidation of fats and oils leading to bad smell and taste. Prevention, refrigeration, airtight containers, adding antioxidants, and nitrogen flushing. 9. Exothermic and endothermic reactions. Exothermic reactions release heat, while endothermic reactions absorb heat, such as photosynthesis occurring in the chloroplast. 10. Importance of chemical equations. Shows reactants and products, indicates physical states, shows reaction conditions like heat or catalysts, and helps calculate quantities. Understanding these equations helps us calculate quantities and see exactly how the world works at a molecular level. I hope this session helped you clear your basics. If it did, don't forget to like this video and subscribe to Singh Classes for more educational content. signing off. Keep learning.